One of the things that we're doing is really novel is we're actually reanimating human hearts as well as on a weekly basis. We're reanimating swine hearts, very similar between swine and humans. And we're looking at the functional anatomy.
This is an isolated swine heart. I work predominantly with isolated human hearts that we get from organ donors. So those hearts are not deemed viable for transplant, so we take those hearts and we do research on them.
And just like a heart transplant, you have 4 to 6 hours before you need to reanimate that heart. The visible heart is a unique apparatus and system where we basically can put the heart, cannulate all the great vessels, and then we delivered a clear buffer that tries to best simulate blood. The only major difference is we don't have any red blood cells in there. Red blood cells wouldn't allow you to visualize any of the functional anatomy. We'll get it to beat on its own in a native rhythm, which means that we'll get them to have cardiac outputs as they would inside their bodies. Then we'll put high resolution videoscopes or fibroscopes inside the various chambers or vessels of the heart. And then we can visualize all the dynamic functioning of the heart, movement of the valves, papillary muscles, and just movement of the heart chamber walls themselves. Then we can look at the nuances and variations in anatomy. This is critical for design engineers. So if you're going to design devices, for example, a pacing lead or a defibrillation lead or a transcatheter valve, no two human hearts are the same. Disease states can change a heart's mass from 300 grams all the way up to a whole kilogram. So there's remodeling the heart related to disease, and then upon treatment you can get reverse remodeling. All those things have to be kept in mind when we're designing specific devices that either are going to stay in that heart permanently or used as a therapeutic standpoint for a temporary treatment. We have a great industrial collaboration with Medtronic, so we get to see cutting-edge technologies, the prototype devices, and then really see how they work in a heart in a really novel way.
So the heart will last 4 to 5 hours. We're able to do a number of different studies on one heart. You got the left ventricle and the right ventricle, so that shows that we're getting good contraction of the heart. And over on the right-hand side, the ECG. So we're able to look at the electrical conduction system, make sure the heart's still working in normal sinus rhythm.
Our lab has actually had the opportunity to reanimate 46 human hearts in the last 10 years. We actually have a whole free access website that anybody can go online and see the functional anatomy from these human hearts, a unique 3D perspective on really how the inner workings of the heart occur on a beat-by-beat basis. I've been reanimating hearts for the last 14 years, and it doesn't matter if it's a swine heart or a human heart, it's still exciting. You learn something new every time you do it.